that in today's lesson, what we'd like to do is to start to multiply binomials and trinomials and polynomials. So let's look at an example and see how it might go. For example, in our work yesterday, we looked at something such as 3x squared times a 2x cubed. And here notice we have a monomial times a monomial, and of course we can look at this and say immediately that it's equal to, Glenn? 6 times x raised to the 5th power. Does everyone agree with that? And you say, oh, that's quite simple. Now, let's take another example in which we will have this monomial of 3x squared, and now let's take a binomial, say, such as 2x cubed minus 3x. And notice indeed all that we're using here is our distributive property. And looking at this then, who would like to give us what this product is, Malcolm?
6x to the 5th.
We have 6x to the 5th
Minus 9x.
minus
X
9
cubed.
times x
Cubed.
cubed. Does everyone agree with that? And then let's now go to the next step of generalization perhaps, in which we were to have, say, 3x squared minus 2 times a 2x cubed minus 3x, and now in this case we have a binomial times another binomial. And rather than going directly to what you might think of as a final step, let's indicate the process that one goes through when you handle a problem such as this. And notice what we're going to do is to use our distributive property twice, namely 3x squared times 2x cubed minus 3x, and then what then you think we might want to write here? This then is going to be what? Minus 2 times, and again we would like to have the second factor of what? 2x cubed minus 3x, all right? Now, in fact, this gets us right back to the step as we had in example number 2, in which, again, you would like to use your distributive property, and who would like to multiply this one out for us? Doug? What do we have?
6x to the 5th
6x to the 5th
minus 9x cubed
minus 9x cubed
minus 4x cubed
minus 4x cubed
plus 6x.
and a plus 6x. Does everyone agree with that? And now looking at this, you say, well, I think I can, I have some similar terms or like terms here. So a more simple name for this then is, Kirby?
6x to the 5th
6x to the 5th.
minus 14x cubed.
Well, we have
13x
9 and 4 is 13x cubed
plus 6x.
plus 6x. Does everyone agree with that? And this then would be the most simple name for this expression. Well, let's then look at another example, and suppose, again, we were to take, say, this binomial of 3x squared minus 2, and now let's take some, oh, perhaps a trinomial. And let's just repeat our first two terms of 2x cubed minus 3x, and let's say plus 4, and see what we can do with this. In this case, rather than putting in every step as we did in example 3, in which we are then going to have our distributive property, let's see if we can't do that part in our head and actually multiply it out. So who then would like to do this much in his head here, Tom?
6x to the 5th
There we have 6x to the 5th
minus 9x to the 3rd
minus 9x cubed
plus 12x squared.
plus 12x squared. Does everyone agree with that? All right, keep going, and then you still have
Minus 4x cubed
minus 4x cubed
plus 6x
plus 6x
plus minus 4
minus
8.
8. Very good. Now looking at that, you say to yourself, well, I see at least one set of like terms that we have here. So Michael, the final result then, or the most simple name for this product is
6x to the 5th
6x to the 5th
minus 13x to the cubed
13x cubed
12x squared
plus 12x squared
plus 6x
plus 6x
minus 8.
minus 8. All right? And in fact, I don't think that there's anything new or unusual or different about what we are doing here, but rather this is simply review of what you have done from your Algebra 1 course. Well, what I'd like to do now is to look at one of these examples. Suppose, for example, we came back here to example number 3, and let's repeat that, in which we have here 3x squared minus 2 times a 2x cubed minus 3x. And what I'd like you to do is to get into the habit of looking at a binomial times a binomial and trying to, in fact, go right to the final result immediately. And what I mean by that is, if you were to look at this and say to yourself, well, I really am interested in the product of the first two terms here, that product is going to be what? We have there 6x to the 5th power, is that right? And then what I am concerned with is the product of these two terms, these two factors rather, and then the product of these two factors. And in fact, I'd like to do those and add those or combine those in my head if I possibly can. And so what then do we see here? There's a negative, what? 4x cubed. And here we have what? A negative 9x cubed. And then that adds up to negative 13x cubed. And then finally, you see here a negative 2 times a negative 3x. And then that is equal to what? A plus 6x. And you go immediately to your final result. Now again, I don't expect you to put in all of these arrows and these squares, these lines and what have you as you do this, but I think that you can think of that pattern in your head as you're actually performing these products. Well, let's look then at another example. Perhaps the case of, say, a plus b times a plus b is more of a pattern that we're going to be interested in. And if we then were to look at this, you say to yourself, oh yes, a times a is a squared, and then there's b times a, which is a times b, and here we have another a times b, and this product then, and the sum of that product is going to be what? Plus 2ab, and then finally we have the product of these last two terms, which is b squared. In fact, this expression, this product of a plus b times a plus b, you know, can be written as a plus b, the quantity squared, and it is such a popular type of pattern that indeed it's one that I expect you to know. And just looking at this, you say to yourself, well, it's the square of the first term, which is a squared, plus twice the product of the two given terms, which is then going to be what? 2ab, and then plus the square of the second term, which is b squared. And not only is that pattern particularly important, but suppose we had a minus b, the quantity squared. It then may be written as the square of the first term, which is a squared. Now notice here it's a minus sign, so it's going to be minus twice the product of the two given terms, which is minus what? 2ab. And then we have the opposite of b times the opposite of b, which is a plus b squared. Very good. And then finally, suppose we had a situation in which we had, say, a plus b times an a minus b. And looking at this, we have a times a is a squared. Here is a plus ab, and a minus ab is 0. And we have b times the opposite of b is minus b squared. And indeed, that's what its product is. Well, let's look at one or two examples of these situations. Suppose, for example, we had, let's say we had 2x plus 3y, the quantity squared. And what I'd like you to do is to just look at this and think of the pattern that we have just developed and be able to write the final result here. And someone who hasn't said anything yet, Peter?
4x squared
We have 4x squared plus
12.
well, it's going to be twice the product of these two given terms, which is
12xy.
12xy. Does everyone agree with that? And then plus 9y squared. Everyone agree? All right, suppose we then had another example, such as, let's look at 3x minus 2y, the quantity squared. All right? And what then may we say about this? And someone, Bill?
You would say 9x squared
9x squared
minus 12xy
minus 12xy
plus 4y squared.
plus 4y squared. And just remembering what the pattern of a minus b, the quantity squared, is, I think then you can go immediately into your final result. Well, let's look at another example. Suppose we had something such as 3x plus 2y times a 3x minus 2y, and this then is our pattern of a plus b times an a minus b. Again, I would like you to think about patterns rather than about specific elements as you have here, specific terms as we have in any of our examples. And once you see what the pattern is, that immediately, I think, points a direction in which you should go. So someone else who hasn't said anything, Brenda?
That's 9x squared
9x squared
minus 4y squared
minus 4y squared, and in fact I think you're done. Is that right? Well, let me give you some homework problems, which is then going to give you practice in working with these products, and I think that's all that we need to do for today.